I'm Amrita from Institute of Aeronautical Engineering, Department of Electronics and Communication Engineering. My Tech Talk topic for digital design through VHDL is simulation and synthesis, explained in VLSI design flow. Introduction to VLSI design flow. So coming to the abbreviation of VLSI, very large scale integration. The VLSI design flow encompasses several stages from conceptualization to fabrication. Simulation and synthesis are two critical phases in this process. Understanding these phases is essential for efficient and reliable chip design. Overview of simulation in VLSI. Simulation involves modeling the behavior of the digital circuit before fabrication. It helps verify the correctness and functionality of the design. Different types of simulation are used at various design stages. So here we can see the physical design flow. Here the first step is to define the width of the height at the core of the die. So here we can see the types of the simulation in VLSI design. So functional simulation checks the logical correctness of the design. Timing simulation accounts for delays and ensures timing constraints are met. Power simulation estimates the power consumption of the circuit. So here in the right side we can see the VLSI design flow. Design specification, first one. Second one is the architecture design, to the gate level design, to the circuit level design, and coming to the HDL coding, to the simulation, verification. If it meets, and yes, it will go to fabrication. If no, again it will go to the HDL coding, and this process will continue until it meets yes for the fabrication. This is the VLSI design flow. Coming to the functional simulation. Functional simulation verifies the logic of the design against specifications. It uses test vectors to stimulate the circuit model. This simulation is performed using HDL languages like VHDL or Verilog. So here we can see here the flowchart of it. Architectural description. Coming to the down, we can see the partitioning into the high level blocks. Here we can see down the designer's mind to the gate level representation. Coming to the designer's mind, here we'll get two constants where design constant and standard cell library for designer's mind, so that it will give to the representation in the gate level. If it meets a design constraint, then it will optimize gate level representation, or else it will go to the designer mind for thinking about the design constant and the standard cell library, and this process continue until it meets the gate level optimized representation. Timing simulation. Timing simulation incorporates delays and parasitics in the design. It ensures the circuit operates correctly at the target clock frequency. Timing violations detected here can be corrected before fabrication. So here we can see the VLSI design flow. Specifications to architectural design, to RTL coding and functional verification, to logic synthesis, to logic verification testing, to the physical design to the physical verification and sign off, to the fabrication, packaging and testing. This is all comes to the chip. So this is a VLSI IC design flow. Power simulation. Power simulation estimates dynamic and static power consumption. It helps optimize the design for lower power usage. Power analysis is crucial for portable and energy efficient devices. So here we can see the ASIC design flow. Simulation tools in VLSI design. Common simulation tools include ModelSim, BCS, and Xilium. These tools support HDL based simulation for functional and timing analysis. They enable designers to detect and correct issues early in the design process. Introduction to synthesis in VLSI. Synthesis converts high level HDL code into gate level netlists. It automates the mapping from RTL to hardware primitives. Synthesis is essential for translating design specifications into physical hardware. Types of synthesis in VLSI. Logical synthesis optimizes the logical representation of the circuit. Technology mapping adapts the design to specific fabrication processes. Post synthesis optimization improves circuit performance and area. HDL to gate level netlist. Designers write RTL code in languages like VHDL or Verilog. Synthesis tools analyze the RTL and generate a gate level netlist. The netlist describes the interconnected logic gates implementing the design. Optimization goals in synthesis. Synthesis aims to minimize power, area, and delay. It applies various optimization algorithms during the process. The resulting netlist should meet the design specifications and the constraints. Technology mapping. Technology mapping replaces logic gates with library cells compatible with the manufacturing process. It ensures the design is realizable with available transistor level components. Proper mapping influences the overall performance and power of the chip. Synthesis tools and techniques. Common synthesis tools include Synopsys, Design Compiler, and Cadence Genus. Techniques like Boolean optimization and retiming the improve the design. Synthesis outputs are verified through simulation before proceeding further. Role of synthesis in the VLSI flow. Synthesis bridges the gap between high level design and physical implementation. It, reduce, it reduces the manual effort and improves design accuracy. Proper synthesis ensures the design is ready for placement and routing stages. Interaction between simulation and synthesis. Simulation verifies the correctness of the RTL code before synthesis. Synthesis produces a gate level netlist that can be simulated for timing and functionality. Iterative feedback between these phases improve overall design quality. Challenges in simulation and synthesis. Handling large and complex designs requires significant computational resources. Ensuring accurate timing and power models is difficult yet essential. Balancing optimization goals such as area, speed, and power remains challenging. Best practices in VLSI simulation and synthesis. Early verification with functional simulation helps catch errors early. Using constraint synthesis guides the tool toward meeting design goals. Continuous validation with both simulation and synthesis results ensures reliability. Summary of simulation and synthesis in VLSI. Simulation validates design functionality, timing, and power at various stages. Synthesis transforms RTL into optimized gate level representations. Together, these processes are vital for successful and efficient chip manufacturing. Coming to the conclusion, mastery of simulation and synthesis is crucial for modern VLSI design. They ensure that the final chip meets performance, power, and area requirements. Continuous advancements in these areas will drive future innovation in semiconductor technology. Thank you.